Welcome to the Puzzle of the Week series. I am Łukasz and today we'll discuss recursion in Java. Our goal for today is to calculate big Fibonacci numbers. We start with 20,000th number and recursive version of algorithm. As you can see, we were able to generate this number quite quickly. Now let's try to do the same for 30,000th value. And this time we received Stack Overflow exception, because we exceeded maximum level of recursions for given JVM target. So let's consider what options do we have to solve this problem. First, what we can do is to increase thread stack size. We can do this by applying JVM flag XSS. So let's do this for our test configuration. For our purpose, 4 megabytes should be sufficient. So let's back to our test and rerun it. As you can see, this time test passed and we managed to generate expected number. If we cannot afford for stack size increasing, we can consider replacement for the iterative version. So firstly, let's remove a JVM flag that we applied before. And then let's go to the iterative version that I prepared. As you can see, this version isn't more complex than the recursive version. Now let's check if it's working. So as you can see, it's working, and it proves that in many cases, it is worth to consider replacement to the iterative version. Another option is to stick with the recursive version and apply tail call optimization, which prevents the growth of the thread stack. JVM languages such as Kotlin or Scala have support for this functionality. Please note that this optimization only applies to functions that are tail recursive, meaning that the recursive call is the last operation in the function. Other functions won't benefit from this optimization, and it is worth saying that our function fulfills this condition. Now let's check how this optimization can be enabled in Kotlin. As you can see, this version is the same as recursive version written in Java, but additionally we enabled tail call optimization by applying keyword tailrec. Let's check if it will work. As you can see, this approach is also working. If we have to use Java, we can implement the tail call optimization mechanism by ourselves. How to do this is well explained by Pierre-Yves Samon in his book Functional Programming in Java, or in his blog. Let's check how we can do this. He proposed to implement abstract class tail call with 3 methods: resume, eval, and isSuspend, and 2 implementations of this class. So first is return, which is wrapper for returned value, and here eval method returns this value, isSuspend returns false, and resume is not supported for this implementation. And the second implementation is suspend, which is wrapper for next recursion invocation, and it is stored as a supplier of a tail call type. And here eval method firstly invokes resume until it receives objects of a return type, and then it invokes eval on this object. isSuspend method returns true in this case, and resume returns result of a supplier. Author also introduced 2-factor method for creating objects of return and suspend classes. Okay, so let's check how we can use this mechanism in our code. So let's back to the recursive implementation. So here we have to make slight modification in the recursive function. So instead of big decimal, we have to return tail call type. And all returned value should be wrapped into the return type. And recursive invocations into the suspend type. The last thing what we have to do is to invoke eval method on the result of the calculate Fibonacci function. And basically that's all. So let's check if it will work. As you can see, it successfully generated Fibonacci number. In this episode, we learned what to do when we reach the limit of recursive calls in our code and encounter Stack Overflow exception. We have several options here. We can increase the stack size, refactor the algorithm into its iterative version, or employ tail call optimization by choosing a language that supports it, such as Kotlin or Scala. Alternatively, you can implement such a mechanism yourself. That's all for today. See you next week.